Okay, so first we're going to solve this equation for x. So if this was x squared equals 343, I take the square root of both sides, right? So it's the same kind of deal here, except I'm going to take the cube root of both sides, okay? And the cube root, we're going to write that like so. Okay, so I've got a radical and my index, this is called the index, is 3. If it's a square root, we don't write 2 in there because that's just the most common type of radical. So it's assumed that it's a square root if we don't have the number there. But this is a cube root. So I'm looking for something multiplied by itself 3 times that will equal 343, okay? Now, with a square root, we do positive or negative when we take the square root of both sides in front of the radical, but we don't do that with cube roots because a negative times a negative times a negative is going to end up negative. So this has to be a positive number. There's not going to be a negative root that works for, not going to be a negative cube root that works for a positive number, okay? So one way to handle this is with a calculator like this, okay? So we've got our square root button. You'd hit second and then this x squared button, but that's just going to give me the square root of 343. So, 18.5 roughly times itself would equal 343. So that's not going to work. So what I have to do is hit this math button right here, third button down on the left, and then you can see this fourth option here is the cube root. Say you wanted the fourth root or the fifth root or the sixth root, well, you could use this to get to that, okay? If you wanted the seventh root, you'd hit 7 first on your home screen, then choose this. Some calculators will give you a little cursor in there. Anyways, third root of 343. So I got 7. So this is telling me that 7 times 7 times 7 is 343, and it is. Okay. Now, if you don't have another way to handle this, and this comes up later in the book, but I'm just going to tell you about it now because it's sometimes useful. So taking the cube root of 343 is the same as doing 343 and raising it to the 1/3. Okay? So if you're taking the square root of something, that's the same as raising it to the 1/2. Okay? So let's try this out. I'm going to do 343, then I'm going to use my exponent button right up here. And I'm going to raise this to I'm going to put this in parentheses just to be safe, so my calculator doesn't raise it to the first and then divide by 3. So I'm putting this in parentheses like so, and let's see if we get 7. Look at that, we do. Okay, so that's another way to handle it. Okay, so a difference of squares. There's our formula for that as covered in the last section. Sum of cubes is not factorable as covered in the last section. As a difference of cubes and a sum of cubes, these are both factorable, okay? And the formula is a little bit longer. So here's how it looks for a difference of cubes. So it starts out with a binomial like that. It's kind of the same format, right? This one's going to start out like that. So a difference starts with a minus there, and a sum starts with a plus there, okay? And then we've got a trinomial in the next parentheses. And for difference of cubes, it's going to look like this. Okay. For a sum of cubes, it's very similar. There's one little difference in this trinomial, and it's right there. Okay. So I learned a little acronym from a student once to memorize how this goes. It's really, you kind of got to just memorize the formula, but then it's making sure you don't mix up the signs because these two formulas are so similar to each other. Okay? So, the word soap, S-O-A-P. This is the same sign, and I mean just the same as if it's a difference, so it's a negative, okay? The second one is opposite. So I changed my negative to a positive, okay? And the third one is always positive. Okay, and if you take your first letters, S-O-A-P, soap. So that same format works here, right? This would be the same as this original sign. This would be the opposite from the original sign, and then always positive is that last sign. Okay, so that's just a way to help you remember at least the signs in the formula. Okay, so let's try this out. First off, I've got factor completely. So, you would want to check for a common factor. There isn't one here. Okay, so I'm just going to tell you that to save us some time. And then, with two terms, first thing I check is difference of squares. It's clearly not a difference of squares. Now we have these two other options. And hey, it can't be a difference because we've got a positive there. So I'm thinking sum of cubes, okay? So to make sure, I have to check if 343 is a perfect cube. So I want to find the cube root of 343, which I already did, right? It's 7. So I know this is going to be 7x times 7x times 7x here, okay? And then 729, I also want to take, and this is an integer, you could just start doing some guess and check. But I'm going to do the cube root of 729 with my calculator. Whoops, wrong button. What am I doing? Lost. Okay, that's because I hit second. I want to hit math, and then cube root, and 729. So that's 9. Okay, so this is 9 times 9 times 9. So that means for this problem, 7x is my A, and 9 is my B, okay? So let's follow this format then, okay? So it's going to start out with A plus B. So A plus B, so 7x plus 9, okay? And then what I like to do for the trinomial is to set up blank parentheses. It's really going to help to keep things in order, okay? Otherwise, it's really easy to mix up your signs. So these first two slots here are the A slots right here and here, right? So that's where I'm going to put the 7x. And then the last two slots are the B slots in the trinomial, so that's where the 9s go. Okay? So I'm going to leave this binomial alone. That's just going to stay 7x plus 9. And then I want to start simplifying. So part of the reason I have the parentheses, I got to remember this is 7x times itself. It's not just 7x squared, because it's 7x times 7x. That's going to be 49x squared. Okay? And then 7x times 9 is 63, so I'm going to be subtracting 63x. Okay? And then 9 times 9 is 81. Okay? Now, it's tempting to look at this and think, oh, I've got this quadratic trinomial. Maybe I can factor that. So, I could try doing a modified diamond problem or something like that. If in the original problem, if you factored out common factors, the trinomial is not going to be factorable. So you don't have to waste your time trying to factor it. So that's pretty good news there. But, got to make sure that you look out for for common factors at the beginning. Okay? So on this next one, case in point, this does have a common factor. Okay, so it doesn't look like a cube right now, but let's factor out 5x first. So it's going to look like that, okay? And now I do have cubes. X to the third is x third, 2 to the third is 8, okay? So when I'm setting this up, this is a difference, so make sure you use the right formula. So I'm doing a minus b first, x minus 2. Then I've got my trinomial, and I'm going to set this up using blank parentheses. Make sure you get your signs right in there. Okay? And let's see, the first two slots are the A slots. And then second two slots are the B slots. And then start simplifying. Still got the 5x out there. And 2 squared is 4. And you can, that trinomial, whoops, I'm off screen. That trinomial is not going to be factorable. You can try it if you like, but it's a dead end. And then so there's our solution. Okay, on to the next page. We're going to look at quartic trinomials. Okay, and this works a lot like quadratic trinomials, but instead of x squared minus 5x equals negative 14, I've got x to the fourth and an x squared term here. Okay, so what I'm going to do is set this up with a diamond problem, just like I would with a quadratic trinomial. So I'll put the negative 5 on top, negative 14 on bottom. I'm looking for two numbers that add to negative 5, same two numbers multiply to negative 14. Okay, so I'm brainstorming how to multiply to get negative 14. there are 4 different ways that I can think of using integers. And only one of those is going to add up to -5, so there's my winning combo, 2 and -7. Okay. Now, here's the difference. When I'm setting this up, the diamond problem tells me what goes at the end of each parentheses. What goes at the beginning usually would be x. I'd have x to the first, x to the first. But to get x to the fourth, I'm just going to have x squareds in both those positions instead. Okay? And then I still put the 2 at the back of one of them and the -7 at the back of the other one. Okay? And then this is factored. And I'd still want to check. Sometimes you might end up with a difference of squares or even a difference of cubes, because this will also work if we had something like x to the 8th and -5x to the 4th. Actually, x to the 8th wouldn't work, but if we had x to the 16th, let's say, because then we could have x to the 4th at the front of each of these, okay? But anyways, just check to see if we can do any more factoring. This one, we can't, so that one's finished. We've got a sum of well, it's not cubes anyways, or squares. But let's try this next one. Same kind of deal. I'm going to set up a diamond problem. The difference here is that I know this is going to begin with x squareds if it is factorable. Okay, and then let's see, 12. And I've got the double negative versions of these as well, but I know it's going to be positives to get to a +7. So 3 and 4 is my winning combo there. And there we go. So again, this is a sum of squares. If it were a difference of squares, I'd be in business, and I could factor more, but that one's finished. Okay. All right, and then next up, I've got, I'm going to use synthetic division to determine if x plus 2 is a factor of this. So one way to handle this would be to try to factor this. We could potentially factor this. It looks like it might work with grouping. So you could just factor it and see if x plus 2 is a factor. But there's a quicker way to do this. That'll work even if we have a polynomial that we can't factor. Okay? So if the remainder is 0, then it's a factor. And if the remainder is not 0, then it's not a factor. So that means I can just divide. I can check. I can take 3x to the 4th plus 6x to the 3rd minus 5x minus 10 and divide that by x plus 2 and see if I get a 0 remainder or not. If it goes in evenly, that means it's a factor. Okay? I'm going to set this up with synthetic division. You could do long division if you prefer. Check in if there's any missing terms. There is a missing term here, right? There's no x squared term, so I'd want to put a 0 in there when I do synthetic division. I kind of want it in that position if I'm doing long division as well. Oh, what am I doing here? I shouldn't have written the x to the 4th, and I should just want the numbers. That's what happens when I talk and try to do math at the same time. I meant to write this, then the 0, for the 0x squared, -5, -10. Luckily, this won't take up too much space. Okay, so I'm setting up synthetic division, and I'll just see if I get a 0 remainder. That's going to give me my yes or no answer. So I'll pull down a 3. -2 times 3 is -6. 6 plus -6 is 0. -2 times 0 is 0. 0 plus 0 is 0. -2 times 0 is 0. -5 plus 0 is -5. -2 times -5 is +10. Add those up, and hey, I got a remainder of 0. So that means if the remainder is 0, it's a factor. So my answer is yes, it's a factor. If I get anything other than 0, my answer is going to be no, not a factor. Okay? So I'll just answer the next one as yes or no. Okay? I'm going to do synthetic division again. So I'm putting a 1 in that box. So starting out with 2, then I've got 1x to the 3rd. There's no x squared term, so 0x squared plus 0x minus 3. Okay? So I've got the 2 zeros in there to represent plus 0x squared plus 0x. Okay. All right. So let's see if we get a zero remainder. 1 times 2 is 2. 1 plus 2 is 3. 1 times 3 is 3. 0 plus 3 is 3. 1 times 3 is 3. 0 plus 3 is 3. 1 times 3 is 3. And look at that. This is a factor again. So the answer here is yes. Okay? And that is it for this section. See you next time.